Let's look at statements, which are one of our most fundamental programming concepts. So much of the code we write will consist of writing statements. This includes assigning values to variables, updating values to variables, and making function calls. When we're reading our code, though, keep in mind that in general, the code is processed from top down. So that means that if you see multiple statements, they're typically processed in order, which of course affects what values you get. We need to be able to store information in variables and then use the variable names as part of our logic. So if I want to store a person's age, I might create an age variable and assign it a value of 43. And if I want to store a person's name, I could assign it a value like this, name equals Darren. When creating variables, there are some restrictions on what's considered valid. So they all have to begin with a letter or an underscore. This is an underscore right here. Once we get past the first character, though, we also can include numbers as part of the variable name. So age is a valid variable name. First underscore name is a valid variable name. Answer 12 is valid. What isn't valid is to use a keyword as a variable name. Keywords are the terms that are built into the language that have particular meaning to the language. So the word if means something in Python. It's an example of what we call a conditional. So I might write something like, if x is greater than 5, print, you made a mistake. So that's what if would be used for in that case. So it can't be used in that sense and also be used as a variable name. So you never get to use it as a variable name. Also keep in mind that variable names are case sensitive. So within the same program, I could have one variable called name, spelt in all lowercase letters, and have another variable spelt name, but it's capitalized. I wouldn't recommend doing that because it's very easy for a human to get confused looking at this. But to the computer, I might as well call this apples and oranges. It's not going to get confused at all. It's just that humans can easily make mistakes writing this, and then trying to debug it would also be difficult because it's easy to look at this and not pick up on the fact that it really should be this. So I strongly recommend not doing that, even though it is legal. Let's talk briefly about functions. Functions are collections of code that do something. So for example, if I want to calculate the sine of x, I can just call the sine function that's in the math library. So this statement says y will be equal to the sine of whatever x is. And this assumes x already exists. It's much easier to call sine here in the math library than it is to write the actual code to find the sine of x, which is this. This is the mathematical definition for sine, and somebody obviously has to know this in order to get the answer. But in general, you don't want to be the person having to write the code to do this. You just want to do this. Eventually, we'll learn how to write our own functions because they have tremendous use when writing code. Assignment statements are used a lot. We saw that earlier when I assigned a value to age and also assigned a value to a name variable. When looking at assignment statements, keep in mind that the right-hand side is something to be assigned and the variable name itself is what's on the left. So I can never have 14 equals A. That would be illegal. So in this case, 14 gets assigned to A. And then for B, if I really had these two lines of code, B would be equal to A plus 10, which in this case would be 14 plus 10 is 24. That's what would get assigned to B. The right-hand expression can be somewhat complex, but ultimately it needs to simplify down to a value that we can then assign to the variable on the left. And one of the interesting things about Python is we can assign multiple things at the same time. In fact, let's see a few things before we move on. So I could do something like this. A is equal to 5. B is equal to 10. We hadn't seen really what this means yet, but I'm going to go ahead and put this in here. And we can say A is equal to %D. B is equal to %D. If you don't understand what all this means, I'm going to talk about it at the end of this lecture. And then run it. Now, if you're using Python 3, which I am, you typically need to do this. And run it, we see 5 and 10. That's what we expect. But I've typed Python 3 so many times that I've actually created an alias. So since I use Linux, I can create an alias. And I created one for P. And see, whenever I type P, it actually puts Python 3 in for me. So in lectures going forward, you'll probably actually see me do this and still get the same results. What I was stating a moment ago was I can actually do something like this. A comma B is equal to 123 comma 99. And I take that line there. Let's see what happens. A got the 123, B got the 99. So you can't do that in a lot of other languages, but that's one of the interesting things about Python. Another thing that was interesting is this. A comma B is equal to B comma A. Now I just swap the values with this statement. And certainly that wouldn't be valid in most programming languages, but once again, Python allows some interesting things. All right. There are many, many times in which we have a variable and we want to add something to it or divide it by some number or multiply it by some number. And so you think mentally something like this. Whatever the value of A is, add 5 to it. So if A is already 10, I want it to become 15. But how do you write that? Well, remember with the way assignment statements work is this is not an algebraic expression. We're not solving for A here. And so therefore, the way it's actually evaluated is the right-hand side is looked at first. And so it says, what's the current value of A? If A is 10, when we reach this point, it says 10 plus 5 is 15. And now that that has reduced to something, reassign it back to A. So from the computer perspective, it's really no different than saying B is equal to A plus 5. B would get 15, so here A gets 15. Another way to think about it is this is the new value of A, and this is the old value of A. That's the way I think of it. Right? Because we add or subtract or divide or multiply values by something and then reassign them back, there's actually shortcut versions of doing that are available in quite a few languages. So instead of adding 5 to A this way and reassigning it to A, you could just write A plus equal 5. And I'll do that in a lot of my code. And that extends to some of the other standard operators. Here I'm doing plus equal for addition, but I could subtract using this. So this would be equivalent to A is equal to A minus 5. I might have A is equal to A divided by 10 using this. I might have A is equal to A times 4 using this. And that would be equivalent to then I would write A times equal 4. So those get used a lot. An operator that you're not really used to using but gets used quite often in programming is what's called the modus operator. So how does this work? Well, you see in this example here, I have top num is 9, bottom num is 4, and answer equals top num mod, bottom num gives me answer is equal to value of 1. What this gives me is the remainder from the division. If you remember back to when you were in elementary school, and you didn't really know about the decimal part of a number, if you were solving for this, you would have said 9 divided by 4, you'd have 4 goes into 9 2 times. 2 times 4 is 8. 9 minus 8 is equal to 1, and then you write 1 is the remainder. That's what this is. So it gets used quite a bit, and we'll see it throughout my video series. If you're coming from an earlier version of Python, that is the 2.x version, or if you're just programming in 2.x for whatever reason, even though my videos will be using 3.x, you need to know about these differences between the two. There's a number of differences between the versions. That's the reason why they came up with new versions. But these are the ones that have affected me the most because I was using Python long before there was 3.x versions. One of those is printing and the other is integer division. So in Python 2.x, print is a statement, while in 3.x it's a function. So what does that mean? If I want to print something in Python 2.x, like 2.4, 2.7, whatever, I say print space, and then inside these quotes, put what it is I want to print. But in Python 3.x and later, So the X here means like 3.8, 3.5, whatever, all this together. I have print parentheses and then the string inside it. So this is a function call. This is a statement. The other way in which the two languages differ is Python, or excuse me, is integer division. In Python 2.x, if I divide an integer by an integer, I get an integer. Okay? So something like this. Top num is 9, bottom num is 4. If you use your calculator, you're going to have 9 divided by 4 is equal to 2.25 when I perform this calculation. And if you do it by hand, that's what you should get. But 2.25 is not an integer. It's what we call a floating point number. And so in Python 2.x, 9/4 will give me 2. And the way it decides what to do is it actually rounds down. If you're coming from something like C, you also would get 2, but C truncates, which means it cuts off the 2.5 here at the end. That's not technically the same thing, even though in this case it gives me the same result. Where they're different would be if one of these numbers was negative, then they don't give the same result. But anyway, if you write this in Python 2.x, you get 2. But if I write this in Python 3.x, such as 3.6, 3.8, whatever, I will get 2.25. So here's an example of what happens when we use Python 3.x. So here's my numbers again, 9 and 4. And when I write answer float equals top num / bottom num, I get 2.25. But when I write answer int equals top num / bottom num, then it gives me the integer division version, which is 2. Now, if one of these numbers happen to already be a floating point number, it doesn't matter. Even in Python 2.x, if I had 9.3 divided by 4, I'll get the floating point version of whatever that works out to be. Right? If you're coming from another programming language, in particular if it's C or C++ or Java, you may have noticed I never declare types. Well, it turns out Python will try to figure out what type I want for me and then automatically generate that type. So let's look at that. And we'll also see that it does a few things I'm not used to. So let's say x is equal to 12. We can do this to see what type it is. So I'm going to say print, and then I'm going to use the type function. We don't need to print the value. We can see the value. So it's an int, see? But now I can do this. I can turn right around and change it to 45.67 and say, what's its type? And now it's a float. So this object, x, is an int, and now we create a new object with the same name that replaced the old one. So the old one's gone. Now x is a float with this value, 45.67. And I can keep doing this. So I'm going to introduce a few new types, but each of these new types will deserve its own video, which I'll use later. This is just to show you how this works. Let's create several other things just to show how types change. All right, let's do this, and we'll actually write this. I'm doing this so we know which part is which. So 12 is an int, 45.67 is a float, cat is a string. This thing here with the square brackets is a list, and this thing here with the curly brackets is a dictionary. So in every case, Python just figured out what I want it to be. Now there's times that I need to change something. Let's say, for example, I had this. A is equal to 12. We'll do this now. And I say B is equal to, let's say that I want that value, but I want to be able to type float. So there's a function, and notice the syntax highlighting here to tell me this is a built-in function. It understands that. And actually I could have reassigned this back to A, but just to make it clear. I'll put this down here. Or else, let me just demonstrate that really I can do this. And plus it makes cutting and pasting the code a little easier actually, because I don't then have to keep updating it. So 12.0, see how it puts the 0.0 there to make it more clear that it's a float? And then I could do this. Change it to a string. So 12.0 now is a string. And then something we'll use later in some of the other videos will be something like this. X is equal to this. Now you look at this and you think, oh, that's a number, 123. But it's not. It's the characters 1, 2, and 3. And so it's really what we call a string, which once again will get its own video. We see that here, 123 string. That's not necessarily a problem that it's a string unless I want to do math with it, because it makes no sense to try to do this. In fact, if I try that, it's going to tell me you must be string, not int. This is not a string, even though you look at it and think it's a number. It's not a number. I mean, excuse me, it is a string. It's not a number. So I can't add this to this any more than I could add cat to 4. That would make any sense. So what if I do want to use it in math? Well, I might do something like this. B is equal to int, since that's what I want it to be, an int, and we'll put x in here. That will convert it plus 4. So I'm going to have an int 123 plus 4. And now print B. And she at 127, which is what I get right here. So I can convert back and forth, and I could convert it to a float if I need to. So we saw I use the int function, so I could take the floats, convert them to ints, strings to ints, ints to strings. I can do all kinds of things there. And you need to, depending on what you're doing. And let's talk about one remaining thing. For the programs we're going to write, I only really have I only have two ways of knowing if anything happened. One is to print things like we just saw to the screen. If I didn't print, how do I know anything happened? Meaning if I did this, oops, that wouldn't be legal. We would know something happened there. So is this valid? Sure. But if I run it, nothing happened because I didn't tell it to print anything. All it did was create the 3 variables and give them values, but I didn't say print something to let me know what happened. So for us, if we don't print to the screen or write to a file, I don't have any way in my code of knowing anything happened. Of course, many real-world programs just do things that humans don't need to look at, so you don't always do these types of things. But I'm not creating GUIs. I'm not creating network programs that are, transferring emails or whatever. I'm just doing something and then printing the results or saving it to a file. So typically I need to have formatted output. So let's look at this. Now there's several different ways of producing formatted output in Python. We saw some output, but for the most part it wasn't formatted, although I did have an example where I used the percent symbol. But the two we're going to look at are what we call C-style format specifiers, which use %d, and then the dot format option. So let's look at these. So if you're familiar with the C programming language, you're already familiar with using what's called a printf function, like that, and having format specifiers. So let's create a comment here. So in C, I could write something like this. Let's do this. I'll make this a multi-line comment. So I'd write something like this. So this would be in my code. I'd say x is equal to 4, and then I want to print x and say x is equal to %d. Maybe give it a new line, comma x, and then I would put a semicolon at the end. So this says print x, and then where it sees %d, plug in the value of x. Because if I write this, you may say I want to write x is equal to the value of x. But if I say x is equal to x like this, how does the computer know that I really want the letter x here, and over here I want the value of x? Well, it can't. So what I need to do is insert something here that it can use to say, oh, well, I see here you're printing an integer. Where do you want me to put the result? Which may be here. And there's other things. So let's create a couple more variables. So if I create the variables, I'd be doing this. And then I might have float is equal, or excuse me, float f is equal to 12.345, and then I would say x is equal to that, and f is equal to %f, like that. So it looks at these in order. X is an int, so I use %d for that. F is a float, so I use %f for that. If you're used to that, you'll find out that in Python I can do the same type of things. X is equal to 4, f is equal to 12.345, and now I can do this. Print. Notice there's no comma here. And then inside parentheses here, I'm going to put the x and the f. And over here, I'm going to say x is equal to %d, f is equal to %f, and print automatically inserts a new line, so I don't need to do this, but I can if I want an extra one. And in fact, if you don't want that, you have to suppress it. But I'll allow it to happen here, and let's see what it does. So x is 4, and f is 12.345000. So this defaults to give me 6 decimal places, even though the number I told it I want to store, I only specified 3. So I can do a number of things that match up with the C style. So things like this. Well, if I want to format this, what if I want this to be 4 digits worth of spacing? And over here, I want to have 8 digits worth of spacing with 2 of those to the right of the decimal point. So the decimal point itself will count as part of the spacing. So I already had a space right here, and this printed 4 using up 4 columns of spacing. So starting right here, 1, 2, 3, and then the 4. And then for F, it used 8 columns worth of spacing, including a decimal point, but only 2 things to the right, and then it rounded off. Now the rounding only occurred in what I see. It doesn't change the internal representation of F. And so you can see here, this is, so 1, 2, 3, 4, 5, 6, 7, 8. There's my 8 spaces. And then you can do other things if you want. Print s is equal to cat for a string. We'll get to strings later in another video. If I'm only going to print one thing, I don't need the parentheses here, which are forming what's called a tuple. I'm saying tuple. See that highlighted? That actually means something actually. So S. This would be the same in C if I'd created a string, although this wouldn't be the way I'd create it. If I want to print an individual character, so this would be S sub 0 to print the first letter of it. There's the C. Every one of these is the same as what I could do in the C programming language. Now in Python 3.x, they came up with a new way of doing things. I personally use this a lot, but in Python X, there's some alternatives, and there's certain advantages to the new way. So let's say we have this. And let me make a note so I don't forget to tell you this. That's a note to me to tell you something while I'm making this video. So let's say I have this. X is equal dot format. And then I can say X and F. Let's see what that does. Let me print a blank line here. Print. So I can separate these things. X is 4, F is 12.345. So what if I want it to look like some of the others? Well, I can do this. Colon 4D, colon, what did I use before? 8.2, 8.2 F. There's the 4, there's the 12.35. See how these look the same? I can do the same type of things for strings. In fact, I don't think we even need the D and the F. Well, the F you need because otherwise F is telling it there's other ways to format floating point numbers, so the F is necessary to get this certain look. So let's stick to that. One of the things though that's interesting about this is that these placeholders can be used with positions. So let's say I have this. I have print to make it easier to understand, I'll put 0, 1, 2. So it printed this string, 0 here, 1 here, and 2 here. But I can give positions to things. So I could have put here 0 to indicate this is the 0 position. Well, I'm not saying that's what these are, that's what they actually are. You got the same results. You say, so, okay, so what's the big deal about that? Now I say put 2 first, but where's 2 here? Well, 2 is still down here. So this is still position 0, this is position 1, this is position 2. And now I print 2, 1, 0. And I can even do this. Get 2, 2, 2. And these can be used with these as well. That's why the colon is here to separate, because otherwise it sees the 4 and think you're talking about position 4. So I could take this right here. In fact, well, we'll change this. So let's say I said this. I say X, we'll call something new. A is equal to 5, B is equal to 99, and just we'll take these out because it's going to get confusing here in a minute. Or we'll leave this one like this. There's the 599, but of course now I could do this, put the 1 here, and put the 0 here. So now the 99 is the one that's first with the formatting of 4 columns of spacing right there. So it does give you a certain amount of flexibility. So what about my comment here? These things I'm using, whether I use the dot format or the C-style format specifiers, are really not about print. They're really string operations. So really I'm doing this, saying something like S is equal to X is equal to %D, F is equal to %F. Something like that, and then saying print S. All I'm doing is modifying the string first and then printing the string. That's what every one of these is doing. Yeah, did I say that? Let's do this. So see, all I did was that. And the same applies for these. Zero, one, two. So there's some things you can do. You have lots of options, in particular with this, in terms of alignment. Do you want right justified, left justified, all kinds of things. Because I've done a fair amount of programming in C, at least from an academic perspective, I'm used to the C format specifiers, so I tend to use those a lot because they're the same, so I don't have to do a context shift. I'm less familiar with using format, but it does have certain flexibility because these things I demonstrated down here, like this right here or this where I reversed them, would not be easy to do in the C style without just rearranging the terms. I could always rearrange the terms and put 2, 1, 0, but this gives a certain amount of flexibility. So we'll use this throughout my video series to print things to the screen. Once we learn how to read and write files, then we may not print to the screen, we may just write to files. But most of my programs will print to the screen. And even when I write programs for my own personal use in Python, I typically use some type of formatted output. So it's not something that people never really use in the real world. All right? So that's what we have to say about statements and printing and that type of thing. My next video will be on conditionals.